if you have a function, let's say y is equal to f of x, where y, which is the dependent variable, have been expressed in terms of x, which is the independent variable, then that function is known as the explicit function. That is, if y is alone at one side of the equal to sign and the other variable is at the other side, then that function is known as explicit function. The opposite of explicit function is the implicit function, where y have not been expressed in terms of other variable. So let's solve this question. We have x squared plus y squared is equal to 0. This is an implicit function because y have not been expressed in terms of x. In other words, y have not been made the subject, and so it's an implicit function. To differentiate an implicit function, first of all, differentiate every variable in the function. So we are going to differentiate x squared, which is 2x. We differentiate y squared, which is 2y. But anytime you differentiate y, you multiply the results by dy dx is equal to, we differentiate 0 and it's still 0. Very important. Anytime you differentiate y, multiply the answer by dy dx. Okay, so the next thing, we are going to make dy dx the subject. So we keep 2y dy dx here and send 2x to the other side of the equation. That's minus 2x. Then we divide through by 2y dy dx. So we can cancel 2y and dy dx is equal to 2 can cancel out, so we have negative x over y. So to differentiate an implicit function, you differentiate every variable, but bear in mind that whenever you differentiate y, you multiply the result by dy dx, and after that you make dy dx the subject. So let's try this example. We have x squared minus 3xy plus 6y squared is equal to 15. And it's an implicit function because y have not been expressed in terms of x. So we differentiate everything one after the other. The differential of x squared is 2x minus, let this 3 be outside a bracket because it's a constant, and xy is a product, so we will apply the product rule on xy. That is xy, let u represent x and v represent y. By the product rule, u v dx plus v du dx. That is, you maintain u, differentiate v, plus you maintain the v and differentiate u. Okay, so we are going to maintain u, which is x. Then we differentiate v, which is y. The differential of y is 1. But anytime you differentiate y, you multiply the result by dy dx. Plus, we are going to maintain the second variable and differentiate the first variable. The differential of x is 1. Plus, we differentiate 6y squared and it's 12y, then dy dx. We equate it to the differential of 15, which is 0. So now we are going to expand this bracket. We have negative 3x dy dx and negative 3y plus 12y dy dx equals 0. So we group like terms and we are going to make x the subject. So we have negative 3x dy dx plus 12y dy dx is equal to, we send this one to the other side of the equation. We have negative 2x and this is positive 3y. And we factorize dy dx and we have negative 3x plus 12y is equal to negative 2x plus 3y. So we divide through by negative 3x plus 12y. Negative 3x plus 12y dy dx over negative 3x plus 12y is equal to like 2x plus 3y over negative 2, negative 3x plus 12y. So we cancel out and dy dx is equal to negative 2x plus 3y over negative 3x plus 12y. Let's try another example. Okay, so if x squared plus y squared is equal to 2pxy, where p is a constant, find dy dx. So we have x squared plus y squared is equal to 2pxy. So we differentiate everything one after the other. The differential of x squared is 2x. The differential of y squared is 2y, but we multiply the results by dy dx. And 2p is a constant, so we bring it outside and treat xy as a product. By the product rule, we maintain x and differentiate y, and it's 1. But anytime you differentiate y, you multiply the result by dy dx. And we also maintain y here, and we differentiate x. That's 1. Okay, so we have 2x plus 2y dy dx is equal to, we expand the bracket. We have 2px dy dx here plus 2py. So we are going to make dy dx the subject. So let's bring this dy dx to this side of the equation. We have 2y dy dx minus 2px dy dx is equal to, we have 2py here, so we bring this 2x and then we factorize dy dx out. So we have 2y minus 2px left here, and we have 2py minus 2x. So we divide through by 2y minus 2px. So we have 2y minus 2px dy dx over 2y minus 2px is equal to 2py minus 2x over 2y minus 2px. So we cancel out here, and dy dx is equal to 2py minus 2x over 2y minus 2px. We can factorize 2 out here. So dy dx is equal to 2 out, and we have py minus x over, we can also factorize 2 out here, and we have y minus px. So 2 will cancel out, and dy dx is equal to py minus x over y minus px. And now the last example. Given that x squared minus 3xy plus 2y squared minus 2x is equal to 5, find the value of dy dx at the point 1, negative 1. So we are going to differentiate this implicit function, and after that, we replace x with 1 and y with negative 1, and then simplify. So we have x squared minus 3xy plus 2y squared minus 2x is equal to 5. So we differentiate x squared, and it's 2x minus, we bring 3 outside the bracket, we maintain x, this is a product, so we maintain x, differentiate y, which is 1, then dy dx because we differentiated y, plus we maintain y and differentiate x, which is 1, plus we differentiate 2y squared, which is 4y, but we have to multiply the result by dy dx, minus the differential of 2x is 2, is equal to the differential of 5 is 0. We expand the bracket, we have 3x dy dx, then minus 3y plus 4y dy dx minus 2 is equal to 0. So we are going to keep dy dx at this side of the equation and send everything to the other side. So we have negative 3x dy dx plus 4y dy dx is equal to, we send this one there, we have negative 2x, and this will be positive 3y, and this will be positive 2. And we factorize dy dx. So we have negative 3x here plus 4y is equal to negative 2x plus 3y plus 2. So we divide both sides by negative 3x plus 4y. So dy dx will give us negative 2x plus 3y plus 2 all over negative 3x plus 4y. And we are going to fix this point 1, negative 1 into this answer. So we have dy dx at the point 1, negative 1 is equal to, so we replace x with 1 and y with negative 1. We have negative 2 times 1 plus 3 times negative 1 plus 2 over negative 3 times 1 plus 4 times negative 1. So the y, the x at the point 1, negative 1 is equal to, this is negative 2, negative 3 plus 2 over negative 3 minus 4. So the y, the x at the point 1, negative 1 is equal to negative 2 minus 3 plus 2 is negative 3. And negative 3 minus 4 is negative 7. So the y, the x at the point 1, negative 1 is equal to, the negative will cancel out and we have 3 over 7.